Hello everybody, welcome on this live event on LinkedIn of the MD650. My name is Lucas Juncker. I am mobile robotic business developer at Omron. And today I am with Benjamin. Benjamin, can you please introduce yourself?
Thank you, Lucas. Benjamin Fourdrinier. I'm the site manager for the ATCNC. I'm glad to be here with you, Lucas, and to unleash and show this new MD together.
Alright, so today for about 40 minutes we will have some presentation and you will see a real demonstration of the MD650. But first, let's try with some question and answer from Benjamin and I, so to get through this presentation step by step. So, Benjamin, what MD650 means actually?
Okay, so MD means middle duty robot. So we have MD series that we just released. We have two versions, MD650 for a payload of 650 kilograms and MD900 for 900 kilograms.
Alright, and why Omron introduced this new mobile robotic in the portfolio?
So we have long experience with LD, with light duty. We also released HD, heavy duty, for payloads up to 1.5 tons. And recently, we have to fill the gap, and there is a lot of payloads and goods to move within the factory. And we had a gap between 100 kilo and 1.5 tons. So now we have the solution with heavy.
Okay, so right now Omron has the capability to transport every payload up to 1.5 ton, is it right?
Yes, exactly.
Alright, and this robot has a limited footprint, right? So how this robot enable flexibility in the factory? How this adds value in that term?
So we have in mind that there are different types of pallets within the industry, crates, and this size is really efficient. We are just less a US pallet, and we have developed specific features to avoid having big areas, big space within the machines, between the machines. So the space is really optimized, and the software features that we develop closely with beta customers and R&D, in our team, we enable this product.
Alright. You talk about pallets, but is this robot only meant to carry pallets?
No, it's not only pallets. It's any kind of goods within our target industries, like automotive, digital, pharma. So it can be a pallet, it can be a frame for a machine, it can be any kind of payloads.
Alright, yeah, different kind of payload that can be carried by these robots. So when we think about a more high ground level, so this robot is really an intralogistics solution at the end, isn't it?
Yeah, exactly. So Omron has long years of experience in machine automation, and our target is to enable to move from straight machine lines to decoupled lines. And thanks to our mobile technology, we are bringing flexibility within the industrial environment.
Alright, we see in the industry those days that the production lines are being decoupled, as you said. So this technology actually enables to have a modular productions inside the factory?
Yeah, exactly. We have different software features that help us to go accurately near the machines. We have tools like integration toolkit to communicate with existing machines. It can be any kind of PLCs, any kind of MES. We have developed communication. Help system integrator. There is the implementation.
So is Omron only manufacturing mobile robots, or you said before that Omron has a long history in automations? Can we provide other solutions as well?
Yes, exactly. So within the mobile robots, we are using our PLCs, sensors, and so on. So this is where is the benefits. We have fixed machines, mobile machines, protocols that are running together, and for sure, if our customer use our PLC on both sides, then setup time is much reduced.
Yeah, so thanks to our automation technology, we can actually enable intralogistics, right?
Yeah.
From every point of view. Okay.
Yeah, you asked me many questions.
Yes.
Now it's time to show the MD.
Yeah, exactly, Benjamin. Just one question, Benjamin.
Yeah.
Where are we today?
Okay, today we are in ATC Automation Technology Center. So this is where we test new features, and we also help our system integrator and end user to test their real applications. So we have Lego blocks we can replicate the environments and do some videos or live events as we are doing.
Yeah, some feasibility has done for this environment, and today what we want to show you is a demonstration, a live demonstration of the MD650. So as you can see right now, the MD is dropping a pallet on the sand, a static sand, and it will come back so we can have a closer view on the MD650. Now the robot is driving back from the stand, and we will see the robots moving, navigating, and we will see how the robots avoid obstacles. Benjamin, we're talking about the Lego box, as you can see there. These Lego box are unknown for the robots. So how the robots know the environment? We do something what is called mapping. This is saving the environment inside the software of the robot. And then, once the robot is operating, it uses this map to localize and navigate. And of course, at the moment you save the map, you don't know what the obstacles, what people will be around when the robot will be operating. And right now we are simulating this with Lego. So these robots, mobile robots, have the capability to avoid obstacles dynamically. As you can see right now, he's sliding fast, and he will drive all the way to the stand. So let's talk a little bit about the solution, because before we were talking about intralogistic solutions. The value that these robots bring is to automate intralogistic solutions. So on top of it, you have a lifter. This lifter can carry up to 500 kilos. As you know, the payload of this robot is 650 for this version of the MD. As Benjamin explained, you have also the MD 900, but this one is 650 kilos. So right now the robot is driving inside the stand, and thanks to our software and the very well-known features here in Omron, we call it CAPS, Cell Alignment Positioning System. The robots can drive underneath with a tolerance, a final tolerance that has been upgraded for this robot, which is plus minus 4 millimeters, which is quite incredible precision for a mobile robotic technology. The lifter picks up the pallet on the stand, and now it will drive this pallet somewhere else in the shop floor. The idea with this kind of solutions is not only to have a standing stand here and nothing around, as you have in these demonstrations, but of course is to interface stand with other stuff, right? Like a warehouse, a production line. So when you have these nice Omron banners, you can imagine a production line or a warehouse where there is an interface between the stand and the pallet. Okay, you also have a live view of mobile planner. So this is the software we were talking before. So you see the robots, you see the navigations, how it works. Now the robots just arrive at what we call a goal. This is the final position. This is something that we can define inside the software. And now the blue path is exactly the path that the robot is willing to take without obstacle. But there is an obstacle in the path, which is this Lego blocks. So he recomputes his path to avoid it and to bring back the pallet to the stand. On the software, you can see some blue dots and pink dots. So the blue dots are the dots from the main LiDAR, and the pink one are the one for the rear LiDAR. So this robot is equipped with two LiDAR, two lasers, safety lasers. Why two safety lasers? It's because to achieve 360-degree safety around the robot. This is a very important feature that is introduced by the MD650. We already introduced this with a high payload carrier, the HD1500, but here we went even more deeper into making something really safe and collaborative, following the last and more strict standards. Right now you can see that the light of the robots are blinking orange. It means that the safety field of the robot has been adjusted to the size of the stands to enable safety collaborations in every area of the production. Right now the robot is driving back. He dropped the pallet, picked up before, so we have achieved a full cycle, and you have been able to see a real demonstration of the MD650. Thank you so much for that. We will be able, during Q&A, if you like, to go back on the demonstrations. Benjamin and I will stay here, and we can go deeper inside the demonstration, the solution, and so on. So right now, let's do a small wrap up with Benjamin to see the important features of the robot and what this robot brings as a value.
Thank you, Lucas. It was a nice demo.
Thank you so much.
So let me wrap up and make a quick summary of what are the key benefits, key focus for our mobile robots MD650 and MD900. We have 5 main focus. We are following Omron design and quality standards. We have increased the speed, reduced the size, put a lot of effort to have the runtime as much as possible for running application with a minimized charging time. As Lucas explained, we are following the last ISO standards, and we have different functional safety features. And last one but not least, integration within our traffic management, fleet management, with repeatability and the capability to avoid obstacles. Starting with the Omron quality, we released more than 10 years ago the one on the right side, the LD60 and 90. Step by step, we implemented a 250 kilogram payload capabilities with LD250. We released HD, and now we are glad to introduce the 2 new MD in the family. A quick summary of the specification on the MD650 and MD900. We can achieve speed above 2.2 meters per second for MD650 and 1.8 meters per second for MD900. The size is around the US pallet size, and charging time for almost a full charge is less than 30 minutes. If we look around the architecture of the MD, we have, as Lucas said, a 360 coverage with safety LiDAR, different e-stops, foot e-stops, lights. At the front you can see the charging contacts, and on the top you have all the necessary features for customers to integrate the toppers with IOs and mechanical points. As we said, Omron is well known as an automation solution provider. We are using all the benefits of our industrial PC and PLCs within the MD for the AMR control and as well for communication with other systems within the factories. A bit of speed and size. As I said, speed up to 2.2 meters per second, swing radius, which is mechanically the radius of the robot, so we have several competitors where they need much more to turn around. Here it can turn on itself with specific features with selectable autonomy to avoid big space within the factory. And the height has been reduced against our current portfolio, which is 320 millimeter height, which is quite a standard for pallet transportation within the factory. Again, charging time, it's quite fast. From 20 to 80%, less than 20 minutes. And all this data can be monitored within our fleet management system, but also through a web page with ProIQ, which we released a few months ago. Safety. We have 360 coverage with a lot of safety zones that can be modified based on the application. And the key advantage is the dual footprint safety zone. You can imagine to have a payload which is bigger of the MD, and then when you go within the PLD stand, pick up the loads, you increase the safety zone, you go to a machine, you unload, and then you decrease the safety zone. So you can even go faster when you are crossing other entrants. The last key benefit is the integration with our fleet manager. You have different factories already using LB and HD, and you can seamlessly integrate our MD within this fleet management system. There are different toolkits to integrate the communication with MES, WMS, the data analytics with ProIQ, and as you said and you demonstrated, plus minus 4 mm for repeatability with the MD. A new feature which is released now is 3D scanning. So 3D scanning, what is 3D scanning? Today we have only one lane of detection, but now thanks to this new 3D scanning system, we can even see the arms of the operators, and we can avoid, for example, forklifts with forks which are at 1 or 2 meters high.
So if there is an obstacles above ground, at this height,
Yeah, exactly.
so the robots will see all my body, right?
Exactly.
Can you show us that?
Yeah, it's on the video.
Ah, yeah. Ah, yeah, really nice. So this is actually a human, yeah. Okay.
And here is a video that we took some days ago, showing the fleet management system with the MoMA on the right side. You have an MD in the middle, an HD with a lifting system, the cart application on the top left corner, and everything is running under a single fleet management system.
Okay, so here we have integrated all the range of mobile robots in this area, right?
Exactly.
So from LD to HD 1500 and of course with the new MD 650.
Yeah.
Alright.
So, here is the presentation.
Yeah. So now it's time for Q&A. So if you have questions, please feel free to put them on the chat. And Benjamin and I will be very happy to answer to those questions. Let's have a look. So, okay.
Do you have system integrators or partners already providing toppers for ND? Yes. A key activity we focus before releasing ND is to work with customers, system integrators and partners who have lifters like this one, conveyors, and as well solutions fully integrated by our system integrator. So we have already 6-7 customers already working with us to develop solutions and running solutions.
So our historical system integrators and partners that work with us for years has been testing and running beta programs for the MD650 and developing solutions as the one you can see behind me. And they are also working with the end user, the ones that will run these robots inside the production line. So yeah, we have some partners that are actively working on this new mobile robots. Okay, next one. Okay, what is the area that you added on the map in Mobile Planner around the pallet dock? So this area, maybe we can show Mobile Planner. This area is a new area. So in Mobile Planner is a graphical programming language. So basically, you don't have to type scripts. You don't have to be a C++ developer to use Mobile Planner. It's really meant to be easy to use. So we program our fleet of mobile robots. It's important to mention that you don't only program the robot itself. When you are programming the map, when you are defining area, as it's been asked in the questions, this applies to all the mobile robots. So this area is an area to switch the safety zone to go inside the stand. So you can see right now the robot is blinking orange. It means that in this specific area we will be in a different safety settings in order to fit inside the stand. Thank you for your question. How long time do you need to rescan a part of a factory in case of machine line adjustments?
Let's take some real cases with LD and other robots that we have in the portfolio. Redoing a part of this map here can take around 5 to 10 minutes, and adjusting those rules, same amount of time, so an adjustment is done within 30 minutes.
So basically what we do, we take one robot from the fleet, we say to the robot, okay, now it's time to scan the environment. So the robots, we will drive around with the robots. You have two possibilities. The first one is to use Mobile Planner. the software that is running on a computer, or you can use a joystick. You drive the robot around and it will save the new environment. And then it's really easy to insert this new map into the existing map. So you don't have to reprogram all the goals, all the areas. So this can be really fast. It also, of course, depends on the surface of the production. If you have a big surface of production, then it will take longer because you have to drive around, but this is really an easy task, and it's meant to be easy and done by operators. Thank you so much. The next one.
So like another question?
We said everything. So it seems that we said everything. Okay.
We can wait a bit and
Yeah, let's wait a little bit for other questions. In the meantime, let's have another look on the MD. What you can see here, we really define these robots to have optimized footprint and payload carrier. This is the really goal of this robot, to have a robot that is able to carry big payloads, 650, 900 for the MD 900, with a very limited footprint. This helps, of course, to increase flexibility in production line. Okay.
I forgot one.
You forgot a point?
Oh, that's fine. Any other question?
Benjamin wanted to come back on the video. This video is really to show you our capability to integrate different kind of mobile robots. On the left side, you can see the map with all the mobile robots working together seamlessly, going from one point to another, carrying pallets, carrying KLT boxes, different kind of payloads, different size, very flexible way, collaborative. So this is the point where we want to go back. You can also see in the background the MoMA solutions. So what we call MoMA in Omron is a mobile manipulator. Mobile for mobile robotics, manipulator for 6-axis arm. Here it's a TM cobot carrying goods. So we also integrate this kind of solutions in this demonstration. So really this is not only about driving vehicles around, it's really about providing an intralogistics solutions.
Thank you, Lucas.
Okay.
And we are waiting for your inquiries about MD650 and MD900.
Yeah. It has been a pleasure to be with you today. Thank you so much.
Thank you, bye.
Bye-bye.